Is visible now?
Yeah.
Okay, so this is the syllabus and 9 sections basically. So in the first section, it is a mathematical general section, you can say. Okay, in our environment science exam, environment science and engineering exam, the questions are very not that much tough. Okay, from this one, mathematics foundation. In this, linear algebra, calculus is there, differential equation, probability and statistics. Okay, all these things we have to study. Okay. And after this is the environmental chemistry. Second unit in environmental chemistry, we have to study the chemistry from basics to higher level, like covalent and ionic bond. We all have, means you must have read this now because you are from chemical engineering.
Yeah.
You are aware about this covalent and ionic bond, chemical equations, concentration and activity. Okay, because in the exam they are asked the questions like what is the oxidation state of that particular. Okay, so it's that level question they can ask in the exam. Radioactivity of elements, chemical equilibrium, thermodynamics and kinetics of chemical reaction.
Okay.
After that, water chemistry means water quality parameter, BOD, COD, pH, and all these things, turbidity, acid base equilibrium, buffer solution, carbonate system, carbonate composition, depth, and ocean acidification. All these are related to carbonate system. Solubility of gases like Henry law and Raoult's law, all these. Complexation, precipitation, and redox reaction, inorganic and organic contaminant. Okay, this part from this unit, how much you have already means aware about all this topic?
Ma'am, actually in chemical engineering, we deal with industrial chemistry, not.
Okay, not this environmental chemistry.
No.
Great. Okay. After this, soil chemistry means in this soil chemistry, we are dealing with the soil means what the chemistry of organic matters. Okay, like humus and all this, and nitrogen cycle, phosphorus, potassium, cation exchange capacity, base saturation, and sodium absorption ratio. Okay. After this is the atmospheric chemistry, in which we study the composition of atmosphere, because the composition and structure, there are two different things in the atmosphere. Composition means which gas is present in how much percentage, how they behave in the atmosphere. After this, reactivity of trace substances in the atmosphere, the reactivity of other pollutant which are present in the atmosphere. This is smoke, photochemical, and this one smog. London smoke and Los Angeles smoke, particulate pollution, particulate PM 2.5, PM 10, all this. The chemistry means how they are behaving in the atmosphere. Chemistry of ozone formation, stratospheric ozone formation and destruction, tropospheric ozone formation and destruction. Okay, chemistry of stratosphere whole. Again, this includes the ozone formation if we study the this one chemistry of stratosphere in detail. The next section is the environmental microbiology, in which we deal with the microbiological part. Okay, like first of all, we should know about the prokaryotic and eukaryotic microorganism. Basic things means the characteristic of diverse group of microorganism, how we will classify the microorganism, microbial diversity, plant microbe and soil microbe interaction, role of different microorganisms in wastewater treatment, bioremediation and biogeochemical cycling. Okay, the role of different microorganisms in this process, like wastewater treatment, bioremediation in which we use the living organism to remediate. It can be soil, water, you can remediate anything. You are seeing something?
No, ma'am.
Okay. And after that, biogeochemical cycle. Bio means living part, geo in the from this one lithosphere part, and chemical means how there are different cycle. Nitrogen cycle, phosphorus cycle, carbon cycle is there, water cycle is there. Okay, so they are they include all the living part also. If we say the nitrogen cycle, it starts from the atmosphere. Okay, atmospheric nitrogen fixation. After this, it comes to the soil. There are so many bacteria which are present in the soil, okay, which fix this nitrogen. After this, it will convert into the nitrite, nitrate, and after again it go back to the atmosphere. This is the cycle, and okay, we will see all these in detail. Next one is the cell chemistry and cell biology, in which we study the structure of proteins, nucleic acid, lipids, and polysaccharides. This portion we have already studied during our, if you have biology in 11th and 12th. Okay, but we will study here also. Bonds in biomolecules, stereoisomerism in biomolecules, structure of cell, structure and function of cytoplasmic membrane, cell wall, outer membrane, glycocalyx, calyx and chromosome, endospore, storage product, mitochondria, and chloroplast. Whole chemistry of cell.
Okay.
After this, microbial metabolism, anabolism and catabolism, phosphorylation, glycolysis, respiration cycle, okay, tricarboxylic acid cycle, electron transport chain, fermentation, anaerobic respiration, energy balance, all these things comes under the microbial metabolism. After this is the growth and control of microorganism, bacterial nutrition and growth, specific growth rate and doubling time. Okay, this one is the important portion from this one part. Monod model, type of culture, batch and continuous culture, effect of different environmental factors on their growth. Okay, control of microbe using physical and chemical method, how we can control the growth of these microbes. After this is the microbiology and health, pathogens and mode of transmission, indicator organism. Okay, and qualification of coliform using MPN membrane filter technique. Again, this one portion is very important. This one quantification of coliform using MPN.
Okay.
Next is the section 4, water resource and environmental hydraulics. So this is the global water resource, structure, properties and distribution of water, water quality, threat to water resources, water conservation. Okay, next is the surface water resources, in which we this one precipitation, type of precipitation, how we can measure the precipitation. There are so many numericals based on this. Infiltration, evapotranspiration, runoff, hydrographs, unit hydrograph. This is the numerical portion. All stage discharge relationship, reservoir capacity, reservoir and channel routing, surface runoff model, surface water management, rainwater harvesting, and all these things. And next come to okay, so this portion covers the surface water. Next portion covers the groundwater, in which we see the type of aquifers. Okay, these are the different zones which are present in the groundwater resource: confined and unconfined aquifer, porosity, permeability, Darcy law and application. The numericals usually come from this portion also. Next is the environmental hydraulics, in which we see the mechanics, okay, mechanical portion. Property of fluid pressure measurement, hydrostatic force, buoyancy and flotation, laminar and turbulent flow, flow through pipe, and all these things. Okay, hydraulic jump, rapid, everything comes under this one, hydraulic portion. Next is the water and wastewater treatment. Okay, so first of all, water treatment. Water treatment means when we treat the water, raw water to the drinkable. Okay, and wastewater, the conversion of sewage water to the up to that mark, so that we can use it for the different purposes. It can be drinking water, or we can use it for the irrigation also. So okay, so this is the wastewater, sewage to this one to come up to the standards, wastewater, water standards. Okay, and wastewater is a raw to drinkable. So it includes the, first of all, we should know about the parameters of water and wastewater, means basically physical, chemical and biological characteristic of water. After that, only after that we can decide that, okay, this type of treatment we have to give that particular type of water. Eutrophication, thermal stratification, river pollution, oxygen sac curve, everything. This is the theoretical portion. Water treatment method, screening, sedimentation with and without coagulation. Again, this one is also a theoretical portion. Point and non-point source of wastewater. Okay, so this is a numerical portion in which you have to forecast the population, because for the proper treatment method for the wastewater, you should know how much population is present there, how you can design the sewer and stormwater sewer apprentices, preliminary, primary, secondary, tertiary sewage treatment, sludge generation, and all this comes under the this one, wastewater treatment. After that, these are the characteristic of industrial effluent. Okay, so the effluent which come from the industry, which is the concept of common effluent treatment plant, wastewater recycling, and zero liquid discharge, kinetics and reactor design, the reactors which we are using for the treatment of this wastewater. Okay, so this is the kinetics, mass and energy balance, order and rate of reaction, which order, first order, zero order, batch reactor complexity, and plug flow reactor. Next comes the air and noise pollution. Okay, so air and noise pollution, first of all, we should know about the structure of atmosphere. Only after that, we will be able to know about the this one, how the pollutant behave in the atmosphere. Okay, so it includes the different portion like sourcing and quality standard and everything, particulate pollutants, how we can control. Okay, this settling chamber, cyclone separator, ESPs, gaseous pollutant. These are the method for the measurement and control of gaseous pollutant. Air quality management, there are models like Gaussian plume model. We have to study different type of plumes. We have to study in this one, and after this, the noise pollution. Seventh unit is the solid and hazardous waste management. Okay, so it includes the municipal solid waste management, hazardous waste, its management characteristic and everything, soil contamination, biomedical waste, plastic e-waste. Okay, so it is also very theoretical unit. Next is a global and environmental issue. Like at the global level, like greenhouse gas is a global issue, global warming, climate change, urban heat island, acid rain, and ozone. And these are the ecological portion in which we have to study the different type of ecosystem, like what aquatic ecosystem, terrestrial ecosystem, grassland ecosystem, forest ecosystem, biodiversity. There are different type of biodiversity present at different levels. There are different method for the conservation of biodiversity also. Okay, so this come under this portion, section 8. And ninth is the environmental management and sustainable development, in which we have to study about the different type of law which are basically for the environment. Okay, like this polluter pay principle, EPA, national environment policy, all this. And this one includes the environmental management. Indian Standard Organization, they have given this one series is for the environmental management system, environmental auditing, energy, different type of energy, renewable and non-renewable energy, and sustainable development in detail we have to study. Okay, so this is about the syllabus. Okay, now today I'm giving you a brief about the, so that you will be able to let me.
Actually, when I checked the GATE syllabus, it was of IIT route, and this was
Because every time the different IIT conduct this one
okay.
GATE. Okay, so this is the syllabus which I am showing you. This is for last year's. Okay, there is no change in the syllabus. Don't
Okay.
worry.
Okay.
Okay, they have just mentioned because this time the Roorkee is conducting. So, and last time in the 2024 Bangalore conducted. So that is why they have mentioned there on the syllabus.
Okay.
Okay, no change in the syllabus.
Okay.
Okay, you can cross check also.
Okay, ma'am.
The syllabus which you are, and I'm showing this syllabus. Okay, no need to worry, because every time the different IITs conduct the GATE exam. Okay, so basically in this demo class, I'm tell you about the structure of atmosphere, basically. Okay, this one unit in which this is the air pollution and noise pollution unit. So first portion is the structure of atmosphere. Okay, so what is atmosphere? Atmosphere is generally that is the gases, invisible gases which are present around the earth. Okay, and how they are held to the earth by the gravitational force. Okay. Now, the Earth atmosphere are composed of two primary gases. Okay, we know that 78% is nitrogen present in the atmosphere. After that, 28. Okay, these are the approx. Oxygen is present. Okay, so so we are called these two primary gases. That is the nitrogen. Wait 1 second. Increase the thickness. Okay. Okay, so these are the two primary gases, nitrogen and oxygen, and water vapor is also very important gas, but it has its residence time is a few seconds only. Okay, so that is why we only consider the nitrogen and oxygen that back up the life, whereas CO2, hydrogen, helium are abundant with no water vapor in the atmosphere of other. So this is the difference between the Earth atmosphere and the atmosphere of other planets, because we have nitrogen, oxygen, and water vapor, but the other planets, they have CO2, hydrogen, or helium gases in abundant. Okay, because they also have atmosphere, but there is a difference in the composition of atmosphere. Now, the atmosphere, which we are saying that it is an invisible gaseous blanket around the earth, there is a profile of atmosphere, because everybody or because like if I'm taking our example, we also have profile now vertically, or means we can arrange our profile in that year I have completed my graduation, post graduation. Similarly, atmosphere also has profile, hydrosphere also has profile, biosphere also has profile. Profile means which thing, or the composition of the atmosphere. So basically, there is a vertical profile of the atmosphere, that it is comprised of series of layers are present in the atmosphere. Okay, so these layers, they are classified on these bases. First is the vertical temperature distribution, second is the electrical property, and third is the gaseous composition. Okay, so we will discuss one by one. Okay, so these are the bases on which we have classified the layer. Okay, so first of all, we will discuss the vertical temperature distribution. Okay, So on the basis of vertical temperature distribution means how when we go from the sea level to the upper level, okay, to the height, or you can say the vertically, how the temperature changes, and due to the change in the temperature, there are different layers present, because in every layer there is a different temperature. Okay, so first of all, we will see the layers which are present. So this is the exosphere, thermosphere, mesosphere, stratosphere, and troposphere. Now see, we will means remember this, like troposphere is present near to us, or you can say to the sea level. Troposphere, after this is the stratosphere, after this mesosphere, and thermosphere, and exosphere. Okay, so you can remember by using this mnemonic also if you want. Okay, trust me in the exam, like troposphere, stratosphere, mesosphere, thermosphere, and exosphere.
Okay.
Okay, so you have to remember these in the series. Okay. Now see, first of all, we will discuss the troposphere, the layer which is present near to us, or you can say to the ground level. Now the meaning of this troposphere is to change. Tropin means change. Okay, means there is some change in the temperature, there is a complete mixing, or there is a proper circulation of gases in the troposphere. That is why it is called the troposphere. The troposphere is the lowest layer of the atmosphere, which is close to the Earth's surface, where almost all weather phenomena that we experience, like convection, turbulence, and most of the cloud formation occur. Okay, so remember this point also, that troposphere is the lowermost layer. Now see, first of all, you just see this diagram. You can see that there is a 0 degree Celsius temperature. Okay,
Yeah.
and in the y-axis there is height. Okay, now we know that at the ground level, approximately the temperature is on and around 20 degrees Celsius. Okay. So when we go up, you know, when you go to the any hill station, there is a decrease in temperature. We all experience this thing. So when we go up in the troposphere, there is a decrease in temperature. You can see na, that around minus 60 degrees Celsius temperature is there at the height of 10 kilometer. Correct?
Yeah.
After this, there is a height. You can see this is the straight vertical line. So there is a temperature is constant, because in the because atmosphere is just a layer of gases. Okay, so it is not like that there is a some clear cut you can you see the layer. Okay, so there is some transition zone. So this is the transition zone where the temperature remains constant. After this, when we go to the stratosphere comes, there is again increase in temperature. When I discuss the stratosphere, I will tell you the reason behind the decrease and increase in the temperature. It is not like that. You don't have to cram all these things. You have to understand why there is a decrease in temperature in the troposphere, why again there is an increase in stratosphere, because ozone layer is present there and it absorbs the UV radiation. Okay, so I will tell you all this thing in detail later. After this, again there is a constant phase. Again in the mesosphere, there is a decrease in temperature. You can see on and around minus 90, means this is the coldest layer, mesosphere. After that, in the thermosphere, again there is a increase in temperature. Okay, in the stratosphere, there is an increase means from minus 60 to 0 degree Celsius. You can see there is that much increase in temperature in the stratosphere with height. Okay. Okay, so we were on the troposphere. So troposphere is that layer which is near to the ground from 0 to 10 degrees Celsius. Okay, so 0 to 10 degrees Celsius, it is a, first of all, remember this question asked in many time in every exam of environment science, that in which layer all weather phenomena occur. So that layer is a troposphere. Okay. Now the thickness of this layer varies from 7 to 8 kilometer at poles. Okay, you can see now this is the equatorial region and this is the polar region. So there is a difference in layer or difference in height of this tropospheric layer. So it is 7 to 8 kilometer at the polar areas and it is 16 to 18 kilometer over the equator. Okay, now why there is a difference in this one height of troposphere? Now see, the gases which are present in the equatorial region, this is the equatorial region and this is the polar region. When you know the sunlight, the solar radiation, which part receive the more solar radiation? Equatorial part. Temperature is more at equator as compared to polar region. And we know whenever there is a temperature is more, the gases become light in nature. Okay, and what will happen? They will rise to the more height as compared to the polar region, because the atmosphere is heavier here. Gases are heavy because there is no solar radiation, and when gases are heavy, they will do not move to the upper height. So that is why they are get concentrated to only 7 to 8 kilometer. But at equatorial region, due to the warm or due to the high temperature, the gases become lighter in nature and they can rise to the this one height 16 to 18 kilometer. Okay. Now, in this diagram, I told you that this troposphere is 10 kilometer. This is the average height, polar and equatorial height. Okay, so that is why you will see that at some places it is written like 10 to 12 kilometer of tropospheric layer height. Okay, so this is the average of these two, 16 and 7 to 8. Okay, but if someone asks you in detail, so you should tell about this one, that at the polar region height is less and at equatorial region height is more, and you know what is the reason behind this. Okay, now okay, so here you can see why there is a non-uniformity in the thickness of the troposphere. As I told you, that first is the equator get high insolation and strong convective flux. Due to high insolation means incoming solar radiation, so they get convective flux. What is convection? Do you know what is convection?
Convection means heat transfer through fluid and gases.
Okay, so this is the heat transfer. So that is why they get lighter in nature. Second reason is there is a high gravitational pull on atmospheric gases at poles. We know that the gravitational pull is more at polar region as compared to equatorial region. And when gravitational pull is more, it will bind the gases to this one ground surface. Okay, due to force, due to pole, this gravitational pull, the polar tropospheric height is less as compared to equatorial region. Third is the equator has highest centrifugal force due to earth rotation. Now see, if this is our earth, there is equator, this is pole. Okay, when the earth rotates, there is a centrifugal force, and we know that the centrifugal force is more at equatorial region as compared to polar region. So, and we know that during gravitational force, the gases or any material, it get so this is the direction on any material in the gravitational centrifugal force. So what will happen as the centrifugal force is more at equator, so the gases get away from the center as compared to polar region. That is why if this is the equatorial region, so gases can move to the more height or more away from the center as compared to the polar region. This is one of the next reason for the non-uniformity in the thickness of the troposphere. Okay, now this is about the thickness or height of the troposphere. Now we come to the chemical composition of the troposphere only. Okay, now see, there are unique things in the troposphere. That is why all the weather phenomena occur in the troposphere. About 99% of the total water vapor in the atmosphere is present in the troposphere itself. And we know that whenever this one water vapor is more, the weather phenomena will occur. We know that because for the cloud formation, water vapor is necessary, moisture is necessary, dust particles are necessary. Okay, after means due to the condensation of this water vapor, the cloud formation occur. And we know that the 99% of the total water vapor in the atmosphere is present in the troposphere itself. Now the concentration of water vapor varies with the latitude. Okay, with the latitude, you know what are latitude?
Yeah, latitudes and longitudes.
What are latitude?
It's me lines above equator, something like.
Yeah. Okay, from equator to pole, these are the latitude. Okay, 0 degree equator and 90 degree at poles. Okay, and these are the longitude, this one.
Okay.
Okay. Now the concentration of water vapor, it varies with the latitude, because whenever there is a more evaporation, more water vapor will be means water vapor will be more. Okay, so at equatorial region, water vapor is more as compared to polar region. We know in the summers also water vapor is more, moisture is more. We don't, our skin also do not feel the dry, but in the cold means in the winter time we also feel the dry skin. That is why, because the moisture is not present in the atmosphere, water vapor is not present in the atmosphere. Okay, we will see this one relative humidity and all this thing in the different section. Now the troposphere primarily composed Okay, now equatorial region has maximum concentration of water vapor up to 3% and reduces towards the polar region. At the same time, water vapor is more at the surface and decreases with altitude. Okay, now the troposphere primarily comprises of nitrogen 78% and oxygen 21% with very little amount of trace gases like argon, helium and all. Nearly 75% of the total mass of atmosphere is contained in troposphere and thus denser than the overlying layers. Okay, now just remember 2 to 3 points, that 99% of the total water vapor which is present in the atmosphere, it is present in the troposphere only, and 1% is present in the remaining layers of atmosphere. Similarly, the 75% of the total atmospheric mass is concentrated in the troposphere. Okay, and it is denser than the overlying layer, the other layer, stratosphere, mesosphere. It is denser because mass is more, gases are more present in the troposphere as compared to the other layer. Okay, because due to gravitational pull also the gases will come to the downside, means in the troposphere. Now this is the temperature variation. First of all, we will see how the height varies in the troposphere. Second is the chemical composition of the atmosphere, and third one is the temperature variation. Okay, now air temperature usually declines from the Earth's surface with increasing height up to about 11 kilometer due to the fact that air near the surface get. Okay, so this is the thing which I am again explaining. Yeah. Okay, which we were discussing in the first slide also, that the air temperature declines as we go from the ground surface to the upper level. Surface with increasing height up to about 11 kilometer. Why? Because the air near the surface get heated up much more by the earth emitted long wave radiation than the earth which is away from it. Okay, so this is the phenomena when the sunlight get absorbed by the this one you can say the ground surface. Okay, after that they re-emit it in the form of long wave radiation. These are the radiation which hit up our atmosphere. Okay, so obviously the you can say the atmosphere which is present near the ground surface, it is more heated or it has more temperature as compared to the above atmosphere. Okay, now the rate at which the air temperature reduces with altitude is called the temperature lapse rate. This is a term whenever there is a change in temperature with height is called the temperature lapse rate, and the value of it is 6.5 degrees Celsius per kilometer. Means when we go for example, this is 0 kilometer, okay, and here is 1 kilometer, and the temperature here at 0 is 30 degrees Celsius. So when I go to the when I am at this 1 kilometer height, so temperature will 30 minus 6.5 degrees Celsius. Means at each kilometer there is a reduction of temperature by 6.5 degrees Celsius. Okay, so this lapse rate is just an average value of day-to-day variation. Okay, after that the layer is tropopause, this one layer. Okay, this straight vertical line.
Okay.
Now troposphere, as I told you, the temperature is constant, means isothermal layer it is. The bottom of this layer represent top of the troposphere and upper limit as the starting point of the stratosphere, because it is like this now. Here is troposphere and here is stratosphere. So the bottom of this line represent the upper part of the troposphere, and the upper part of this tropopause layer represent the lower part of stratosphere. There are some break in the tropopause where tropospheric air mixes with the stratospheric air and vice versa. These breaks also indicate the position of high wind, typically known as the jet stream. These are the jet stream which are present in the polar regions. Okay, so you don't have to go in detail about the jet stream. This is for the geography and environmental science students. Okay. Having speed exceeding 100 knots or 250 miles per hour. Okay, so this is about the tropopause. Okay, next is the stratosphere, next layer. So it extends up to an average height of 50 kilometers from the Earth's surface. Okay, let me show you. So this is the stratosphere. From the Earth's surface to 50 kilometers, this layer is called the stratosphere. Now see, there are two things. One is the height and one is the width. If I am asking you what is the height of stratosphere, you will tell me 50 kilometers, means it is from the ground surface. And if I am asking you about the width of the stratosphere, so you will tell me about the average height of this one, 10 to 50 means 40 kilometers on and around width. Okay, so remember that what someone is asking, whether it is in exam or in interview. Okay, so these are the two things. Now this is the height. Now temperature rises in stratosphere with the height, as I told you before. The reason attributed is the presence of ozone gas, because we all know that the stratospheric layer contains the ozone layer which protects us from the harmful UV radiation. Now ozone is mainly confined in the lower stratosphere within 15 to 35 kilometer. Okay, that is why this layer is called the strato, because strata means layering. Because in this sphere also there are different layer. One is ozone layer. Ozone layer is only confined to 15 to 30 kilometer, means that this is the 10 kilometer and this is the 50 kilometer. All this is the stratosphere. But in this stratosphere also, the ozone layer is present only from 15 to 35 kilometer. Okay, that is why this layer is called the strato. Strata means layer. Now vertical stratification, where above layer become warmer and lower layer become cooler, make the stratosphere dynamically stable. And I will tell you what is this stable and unstable. Okay, so the atmosphere becomes stable when the above layer is warmer and the lower layer is cooler. So this condition, whenever this condition happens in the atmosphere, that is, we will call it as a stable. We will see this in the later part of air pollution also. Now no convection and associated turbulence is found, because whenever there is a stable temperature, there will be no mixing, no turbulence or no convection occur. Now the level of maximum concentration is found at an altitude of about 25 kilometer above the mid latitudes. Now see, it has no vertical wind. Second. Okay, now the temperature inversion. So now what is this inversion? Inversion means whenever there is an increase in temperature with height. Because in the lapse rate, we see that there is a decrease in temperature with height, and at each kilometer there is a decrease by 6.5 degrees Celsius. But whenever there is an increase in temperature, we call it as temperature inversion. Okay, so this temperature inversion make this layer very stable. I told you that whenever this condition colder layer and warmer layer, means when we go from this layer to upper layer, so there is an increase in temperature, and whenever this condition happen, this is a stable condition, inversion condition. Okay, so whenever there is a stable condition, it do not allow the vertical motion of winds. Thus vertical winds are nearly absent. Okay, and maybe up to few centimeter per second. The incapability of the air to flow vertically is also the main reason why ozone depleting CFC takes so long to reach the height where the sun energy is sufficient enough to break them apart. Because see, CFC, they require high energy to get breakdown. That is why they do not get breakdown in the troposphere. That is why they travel to the stratosphere. Okay, and they get reside over there, and they get they get breakdown in the stratospheric layer because there is a high temperature occur. Okay, and what is the reason why they do not travel above this layer? Because this layer do not allow the vertical wind. That is why it is not go in the further layers. Okay, otherwise it get breakdown in the sun energy, which is sufficient present in the uppermost layers. Now, second is the aviation and jet stream in the stratosphere. Now, unlike troposphere, stratosphere is free from the harsh weather changes and preferred by the commercial aircraft, usually flying at an altitude of 9 to 12 kilometer. Okay, in the lower part of the stratosphere, these commercial aircrafts are flying. Now, however, jetliner face the problem of jet stream. Jet streams are nothing but these are the high-speed winds. Okay, these are arise due to the pressure belts. Are high velocity horizontal air current and located near the tropopause. Okay, so these are the characteristic of stratosphere. And next there is the stratopause. Again, there is a pause after stratosphere. Okay, so this is the pause, this one. Again, there is a constant temperature. The transition boundary layer from the top of the stratosphere to the beginning of mesosphere, that is the stratopause, is isothermal in nature. The air temperature of stratopause remain constant around 0 degree Celsius. Okay, and I told you that this much increase in temperature from minus 60 to 0 degree Celsius. Okay, I think this is enough for the means to decide for the further.
Okay.